I'm Jerry Hall. I'm a Fauquier County, Virginia science teacher at Brumfield Elementary and a science coordinator there. And welcome to episode 5 of Science at Home with Mr. Hall, where we try to take everyday things that you might find in your house and demonstrate some science topics with those things. This is my lab assistant and my neighbor, Bruce. Bruce, what grade are you in?
I'm in 5th grade.
5th grade. At least he is for now. I mean, he may never go back with what's going on. But what's your school?
Grace Miller Elementary.
Grace Miller Elementary. Who's your teacher?
Miss Love.
Miss Love. I know Miss Love. She's very cool. We'll have to share this video with her. Okay, so today we're going to be discussing gases. What are the states or phases of matter?
Solid, liquid, and gas.
Solid, liquid, and gas. So what makes gases different than solids and liquids?
They spread out. The molecules are like more open, sort of. Like,
Excellent. And so what do they do when you put them in a container?
they take it, the shape of it.
Yes, and so liquids will take the shape of the container from the bottom up, whereas gases spread out to fill up the container. And so if I cook popcorn in the microwave or to make coffee, it wouldn't be long before we smell it, right?
Yeah.
Because gases spread out. So I want to have you do something that demonstrates that. So for this demonstration, we need vinegar and baking soda, which has a chemical reaction that gives off carbon dioxide gas, or CO2. So carbon dioxide gas is a result of the mixing these two chemicals together and the chemical change that happens as a result. You also need, you don't need a funnel, but it's just easier. So Bruce, I want you to, I'm going to put this funnel on this balloon, and you go ahead and get a spoonful of that baking soda and put it in here. Alright, now sometimes it helps to, maybe one more. Alright, so now that might be a pretty big reaction, but that's alright. Okay, so the next thing we're going to do, so the baking soda is inside the balloon. We made sure the balloon was dry and we didn't blow it up. We're going to put some vinegar in here. So I'll do that, and then I'm going to have you actually make the reaction. Put some vinegar in here. Funnel helps me keep it from getting all over the table. Okay. So now I'm going to put this balloon over the top of this, and I'm going to have my lab assistant Bruce turn it upside down and go ahead and dump the dump the baking soda into the vinegar. Oh man. Oh, that's a lot. Oh, perfect. That's perfect. That is perfect. So did we just prove what you told us all about gases?
Yeah.
Yeah, so gases expand. So that reaction happened pretty quickly. It's an awesome and harmless reaction that kids can do at home. And as you can see, it can be quite active. But what the gas does, the carbon dioxide, the first thing it does is it pushes all the other air out of it. And then it pushes itself into the balloon and maybe some of the liquid as well. So if I take the top off here, now I have a balloon. Whoa! I had a balloon full of carbon dioxide gas. Worked perfectly. So one more thing I want to do with carbon dioxide gas. Oxygen is a solution. The atmosphere is a solution of oxygen and nitrogen and carbon dioxide and a couple other things. So around us we're breathing this solution, which is a mixture. But carbon dioxide on its own is denser and heavier than the air around it. So oxygen is a chemical that helps fire burn. So this fire couldn't burn if you didn't have oxygen. And same with these candles here. It couldn't burn. But carbon dioxide is used to help put fire out. So I'm going to have Bruce make the same reaction in this bottle here. And I'm going to see if we can pour out some of that carbon dioxide and put out the fire. All right, so go ahead and put 1 fat tablespoon in there. Good, all right. Now I'm going to put this back on here. It doesn't matter what you use, but I'm using this because it kind of it provides a spout. So I'm going to go ahead and add some of this. Now, Bruce, when I do this, I want you to try to take this and pour just the gas on the candles and see what happens, all right? Can you do that?
Okay.
So try not to pour the liquid on there, just the gas. So we're going to wait for the reaction to happen for a second. Because carbon dioxide gas is denser than the air around it, and it should stay in the bottle you to try this. Alright, so go ahead and take this and pour it on the candles. As with any fire, you should have an adult around if you're going to be lighting candles or anything. Go ahead, pour it out. No, not working? Hold on. No? Oh. Let's try it with the lid off here. Alright, so go ahead and try to pour it on here. There, okay, it's starting to work. There, perfect. There, okay, now pour it on that one. So none of the liquid's coming out, it's just the gas. I think I know why it's working here. Try it on,
There you
there
go.
we go. Now do this last one here. These candles have a place for it to go. So there it goes. You can't see it, but it's pouring in there. And see, the candle went out because of that. Because inside here is carbon dioxide gas, which is denser than the air around it. So, Bruce, thank you for helping me out today. I appreciate you joining me on a Science at Home with Mr. Hall. Please forward, like, and subscribe. Hit the subscribe bell. Forward it to anybody you think could use it. And as always, science is all around us.